both I plus j and j plus k. So what's the first thing? What would be a good first step, Josh?
Write ij and jk in
I plus j, you mean?
sorry, I
Yeah.
plus j and jk
Yeah.
in vector form.
So 1, 1, 0, and j plus k is going to be 0, 1, 1. So it's a line through 2, 1, 0 that is perpendicular to both of those. So how do you find out the direction that's perpendicular to both of those?
Cross product.
Cross product of those two, exactly. So you do 1, 1, 1, 1, 1, 0, 0, 1, 1. You're looking at that right there. So you end up with, it's not equaling, but 1 times 1 minus 0 minus 1 times 0 minus 0 plus 1 times 1 minus 0. So what's the vector going to be? 1.
Isn't it 1 minus 0? They're all 1 minus 0.
They're all 1 minus 0?
In the middle.
Oh, it is 1 minus 0. The zeros multiply just times each other. Yep, you're absolutely right. So the vector, the perpendicular vector, is going to be what?
1, negative 1, 1.
1, negative 1, 1. Exactly. So that's going to be the directional vector. Does it ask you, does it tell you what form to use for the line? No. Nah. So you could say v of t is going to be equal, r of t. What's our initial point?
2, 1, 0.
2, 1, 0 plus t times
1, negative 1, 1.
And if you wanted it in vector form, you could write x is equal to 2 plus t. Parametric, thank you. Y is equal to 1 minus t, and z is equal to t. Either one of those would be fine.
The first thing you wrote is the vector form, right?
Yep, that's correct. And then what's the second one called? Yes, it's stuck in your head now, right? Parametric form. And if you wanted, what's the last type? If you wanted to write symmetric, it would be...
Is there a reason for the name?
There's two equal signs.
Okay.
X minus 2 over 1. How about 1 minus y over 1 equals? Good. Okay, another one. Use hands, everybody. Use hands. Is the line through -4, -6, 1, and -2, 0, -3 parallel to the line through those two? How do you figure that out? Yeah.
Will I form the vectors formed by those two
Yeah,
points?
that's all you need to do. Sure. We have A, we'll call that B, C, and D. Does it give you direction?
No.
It just says through those points, right? So let's say if we did A to B, we'd end up with 2, 6, -4. And from C to D, we would end up with what? -5, -15, and 10. So two vectors are parallel to each other if what? If what's true? If what's true?
Direction is the same.
So numerically, how do you
Exact
tell?
opposite.
Or exact opposite. So how do you figure that out numerically? They need to be a what of each other? Proportional to each other. They need to be that all the corresponding components need to be proportional to each other. So we have 2 over -5. Does that equal 6 over -15? And does that equal -4 over 10? Is that true? Yeah, it is true because this simplifies to -2 over 5, and this simplifies to
-2 over 5.
-2 over 5. So everything is proportional. So yes, parallel.
It is that simple.
Yes. It is that simple. It is that simple. What can you do? What's the rule about dot product? What can you do with that dot product? Yeah.
Distribute it.
You can kind of distribute it, exactly. So if you distribute it and bring it out to the other side, you end up with this right here, the vector equation of a plane. Here's the vector equation of a plane. The vector equation of a plane states n dot r equals n dot r naught. That's the vector equation of a plane. That's not the most common way to write the equation of a plane, though. That's just one way. How many different ways do we have to write a line right now? How many ways?
3.
We have 3 different ways to write a line. That's right. We have 3. So is it not so surprising that we're going to have multiple ways to draw to write a plane? No, not so. This. I could say Find an equation of the plane that passes through the point 2, 4, negative 1 with normal vector 2, 3, 4. And right here, passes through 2, 4, negative 1, and it is normal to the vector 2, 3, 4. So if you're given a normal vector and a point, are you done? That's the equivalent. That is the functional equivalent of me saying, what's the equation of a line in 2 space? Here's a point and a slope. Are you done? Yes. If I give you a point and a slope, can you write the equation for a line in a Cartesian plane? Yes. Slope-intercept form, point-slope form, you're done. Now, how could we rearrange that? What would be a really common thing to do if I wanted to clean that up a little bit? What could I do?
Distribute.
No, I don't want to divide. Let's not divide.
Distribute all
Let's
the-
not divide. Distribute. I like distributing. So end up with 2x minus 4 plus 3y minus 12 plus 4z plus 4 is equal to 0. And you might actually see it as 2x plus 3y plus 4z is equal to what? Equal to 12. What's really interesting is you might see it written in this form right here. And they give you the notation for this. We won't draw it right here. What we just did is we turned it into the linear equation. We turned it into the linear equation. What's really interesting about the linear equation is if n is 2, 3, 4 right here, n, that's the vector, that's the normal vector to the plane. Where is 2, 3, 4 living on? Yeah, it's the coefficient. Here's A, here's B, and here's C of the normal vector. So if you're given a line written in linear equation form, what are they automatically giving you? The normal vector. So if you get an equation in linear equation form, do you automatically have the normal vector? And is that super, super, super helpful? Yes, yes it is. Every form is going to give you something really key. You need to know what that is. Does it say anything about the form the equation can take?
Nope.
Nope, can be any type you want. How many different equations describe the exact same plane? Many. Try to make it as normal looking as you can. Don't go out of your way to make it nasty. Their answer, what do they think it was? Josh, what do you got?
6x plus 10y. The normal vector
Yeah,
is the answer.
the answer.
6x
Yep.
plus 10y plus 7z minus 50 equals 0.
7z minus 50 equals 0.
50
So equals 50. Does anybody have something similar to that? But does anybody agree with that? You have the same one? Does anybody have something different than that? Yeah, what do you have?
I have negative 14 times x minus 1 minus 20 times y minus 3 plus 18 times z minus 2
Equals
equals 0.
what?
Equals 0.
Equals 0. So how could we verify that those are the same?
Distribute.
We could distribute. You could really look at the coefficient. The problem is I don't think these are.
Yeah.
They're close because you end up with negative 14x plus 14 minus 20y plus 60 plus 18z minus 36 is equal to 0. So we have negative 14x minus 20y plus it's really close. 18z equals what? We had 1474 minus 36 is going to be 38. Is that true? Did I get that? Can you guys help me here for a sec? You guys are the ones that are much better at this than I am. 74 minus 36. Right? 74 minus 36 is 38, right? Okay, so yeah, what could you do at this point? You could divide everything by 2, and you get negative 7x minus 10y plus 9z is equal to 19. It's in the semi-ballpark, but it looks like something went wrong here.
So which one's right?
Well, we have two people having the same exact answer. I would imagine that this is correct right here. I'm guessing that that one's correct. I'm guessing that something's off.
That should be minus 3.
Should be what?
Minus
It should be minus 38?
3.
No, it's 60 and 14 is 74.
But they moved it to the other side.
Yeah, but oh, it should be minus. Thank you. Oh, yes. Thank you. Then I moved to the other side. So something's up. So how?
Mr. Seamon,
Yep.
Yeah, it should be crossed.
Yes.
how did you get those numbers
Which numbers?
from the top?
These right here.
Second row? Yes.
Wait, that one?
Yeah.
Josh gave them to me.
Where did it come from?
Okay, we'll do it out. Okay, we'll do it out. Fine. So something's up with this. It's okay. We don't kill it. The cross product. Okay, so that's usually where the problem lies, right at the beginning here. Which ones did you do, Josh? Which two vectors?
The vectors I used were 2, -4, 4.
No. Which? Give me the points. P to Q or Q to
I
P?
didn't write them down, but I did P to Q
Yep.
and Q to R, I believe.
So you did P to Q, and that's actually what I would choose. I like starting with P because I think that does it more in the book. So if you go from P to Q, you're going to end
Q
up.
to R.
Yep. P to Q. P to Q is going to be 3 minus 1, comma, -1 minus 3, comma, 6 minus 2. So what's that equal?
-4, 4.
4. Exactly. And then if you do P to R.
I did Q to R, but okay.
Oh, you did Q to R?
Yep.
Okay, we'll do Q to R. That's fine. We'll do Q to R. Looking at the points there, Q to R, we end up with 5 minus 3, 2 minus -1, and 0 minus 6. So you end up with 2, comma, 3, comma. Is that what you got, Josh?
2, 3, -6?
Yes.
Yes.
So now we need to cross them in order to find the normal vector. We need to cross them to find the normal vector. So we end up with 1. I always have to write it out. Sometimes you get good enough. Is it really easy to make a small mistake and have this thing blow up in your face?
Very.
Yeah, so is it in your best interest to be very careful?
Yep.
Yes. So we have 1 times 20. Oh, sorry, I don't need a absolute value. 124 minus 12 minus 1 times -12 minus 8 plus 1 times 6 plus 8. So I end up with 12 comma 20, positive 20, right? Because it's a negative 14 like this. So that's your normal vector. Are we good with that? So then you have 12 times x minus. Now it just totally depends on which point you pick. Which point do you want to pick, Josh? What should I pick?
I picked
P, Q, or R?
I
Which
picked P.
P?
It was the easiest.
1, 3, 2?
Yep.
Yeah. 1, 3. Whoa, I said 3 and wrote 20. And equals 0. And then hopefully it collapses nicely. 12x minus 12 plus 20y minus 60 plus 14z minus 28 equals 0. So you end up with 12x plus 20y plus 14z, which is a good sign. Then you have -72 minus 100 equals, divide by 2 and add the 50 to the other side. So you get 6x plus 10y plus 7z, not 2, 7z equals 50. That's where it comes from.
Quick question.
Yes.
If you
See if you can do this. Try it by yourself. Try something. It's okay if it's wrong. Find the angle between those planes. Find the angle that they form. When two planes intersect, does the angle of intersection change anywhere? No, it's a constant angle of intersection.
that they intersect on.
Well, they intersect on a line, but what's the angle that they form when these two planes intersect?
Wait, they can